u at an angle theta. Now somewhere at a point, somewhere let me pick up some. Look at the velocity vector. I should draw a tangent. Yeah. Now if I extend back this velocity vector and if I extend this velocity, at one instant they may be 90 degrees. At t equals 0 is what I projected. After some time t, it can happen that the velocity of a projectile will become perpendicular to initial velocity, and I want that particular time. This is that maximum height. Tan theta should be equal to Vy by Vx, no? Go back to trigonometry. Okay, I want that time, that time, instant of time at which the velocity vector will become perpendicular to initial velocity of projection. I don't know, say very simple tan theta we have discussed in trigonometry, tan theta equal to V by Bx, theta equal to tan inverse will come. Okay, this is the thing. So what is my question like? Find the instant of time at which velocity vector will become perpendicular to initial velocity vector. Let me give the question. Find time at which velocity vector becomes perpendicular to initial velocity vector. Okay, yeah, Gopichan, yeah, fine. Okay, now at this instant, let me resolve this. This will have Vx and Vy. It can, so what is Vx equal to? We know Vx is equal to Ux I cap. Horizontal component of velocity remains same. Yeah, agreed. Vishal, yeah, fine. Then what about Vy? Vy should be equal to u sine theta plus gt j cap. Now you can ask question like, so this time I'm not sure. It can be here or here. It's an algebraic sum, that is. It can be positive or negative. So if you put negative, it will become only difference. It all depends upon this time. It can be, if it is less than u sine theta by j, it will be positive. Greater than u sine theta by j, it will be positive. So therefore, we are going to go for, this is some sort of like a algebraic sum. It can be positive or negative. Then what is the total velocity vector? V bar equal to Vx I cap Vy j cap. So u cos theta I cap j cap. Then V bar dot u bar, because there is a condition given. So why you are taking dot product equal to 0? Because when two vectors are perpendicular, dot product must be 0. So V bar equal to u cos theta I cap I dot I will be 0. So u cos square theta. Then I dot j. Okay, initial velocity vector. One more thing I'm missing. U cos theta u cos square theta. I'll get I dot I. J dot j will see this one. This will become u square sine square theta plus u sine theta gt, all set equal to 0. Dot product must be perpendicular. J dot g should be equal to 1. So u square sine square theta plus u sine theta into g. So this should be equal to 1, u square cos. So this will become equal to u square plus u sine theta gt equals 0. Then this is u plus but time should not be negative, no? So tell me like where the conditions we have took it in different way.
We should take their minus gt, sir. Vy is equal to u sine.
No, that's what. Let's see anybody wall making. Look at this part. See Vy, this should be positive only because it can be here or here. But look at this sign. How is G is acting? Opposite to a don't disturb class, huh? Okay, look at this one. U sine theta. How is U sine theta? U sine theta will be opposite to G, no? So and
Yes,
whenever we please don't repeat
Sir,
again.
have you got last but one line, sir?
Wait,
u
wait,
cos
wait,
square theta plus.
wait. I'll explain. In the end, you can do whatever you want. Huh? Let me. Don't anybody. Don't unmute. Now look at this. U sine theta. How it is? This is opposite to gravity, no? So whenever we are using equations of motion, what we do is like we always go for the sign convention. Then according to sign convention, this should be the negative. Then, sir, then you should also put sign for this because this will be negative here. I'm telling this one the velocity vector can become perpendicular here or here. Since it can be either here or here, so therefore I had to go for algebraic sum here. But this has to be negative only. This has to be algebraic sum because it can be anything. So here that negative sign. Why that negative sign? It's the equations of motion. This will be as usual. Okay, this will become. Now what is the instant of time? T is equal to u by g sine theta. Okay.
Sir, have you got last but one line, sir?
Okay. Wait. U square minus u sine g theta. Okay, so
that one. Have you got? Not that one, sir. Above that.
I'll rewrite again. Huh? Some of you are getting confusion. I'll rewrite it. This will become u square cos square theta plus u square sin square theta. This will be 1. U square minus u sine theta gt. If you take u common, it will be that one. So finally what do we get is like a u minus okay, now what will happen? We wanted time. Now here this part is something very important. In many numericals, the situation of like this it will come. Please do make notice of this sign. So here it's very clear in the diagram Vy is negative, but still you are taking positive. Because we are just deriving an expression. Vy can be positive or negative. When it can be positive or negative, you should assume a positive sign. Algebraic sum it is, not like additive. Able to understand this?
yes.
Okay, no. This is something, okay, let's do one thing. Let's just analyze this particular condition like, okay, theta equal to 30 degrees, theta equal to 45 degrees, theta equal to 60 degrees. Let's take some 3 angles, we'll analyze what actually that motion, how it occurs here. So first we'll have a column, theta equal to 30 degrees. What is the time of flight? We'll calculate. Then the time at which. How Vx will become plus gt? Horizontal velocity. There's no horizontal component of velocity. Now first theta equal to 30 degrees. What is the time of flight formula? We know other side time of flight of formula is this much. I think it should become u by g. Time of flight will be. Then how much this time will become now? Theta 2u by g. When will become perpendicular? After 2u by g. 45 degrees. Root 2u by g. This is also root 2u by g. When it is projected with 60 degrees. Time of flight. Root 3u by g. 2u by g root 3. Okay, what about the first one, 2u by g? If I project with an angle 30 degrees, when it will become perpendicular? This idea of trajectory is something very important. It will keep on move. Curved path is needed. Now I'm projecting with a speed u at an angle 30 degrees. It will become perpendicular somewhere here. After crossing that particular point, somewhere it will become perpendicular here. Now this will be 90 degrees. This is when first case. I think in numericals we need this background. Now after this, if I project with 45 degrees, when it will become perpendicular? Exactly at the point of striking. Exactly at the point of striking, it is going to become perpendicular. We have projected with a speed u. Here v, 45 degrees, 45 degrees. I think we need this background. Otherwise, just mere formula, if you remember, okay, anything formula based will come, but the analysis you are unable to do it. If it is 60 degrees, then as before point of striking only, it's going to become perpendicular. Very few students who really want to learn. Remaining all what will happen, answer got, okay, they'll feel happy. What is the condition for that particular formula, everything, no, that has to be analyzed here. Somewhere here, now before point of striking only, you see this velocity vector will become perpendicular to initial velocity of projection. This angle is 60 degrees. Okay, everyone is able to this one. So now I think it's very sure, no, like say with what speed you project, it doesn't matter. Am I right? With what speed you project, it doesn't matter. It's all about the angle of projection. If the angle of projection is less than 45 degrees, so greater than 45 degrees, as you can expect before striking only, the velocity vector will become perpendicular to initial velocity vector. If anything it is less than 45 degrees, not possible. In this region, not possible. If it is on ground, I think how do it can go into the ground? So therefore say that velocity vector cannot become perpendicular if angle of projection is 30 degree when ball is projected on the ground. If it is from tower, okay, because afterwards also it can be in motion. Yeah, that's why I brought this time of flights also, you can see. Only here t is less than capital T. Here t equal to capital T this case. For t here greater than capital T. Means before this time not possible. Analysis you have to do, this is very important.
Sir,
Ah,
here you are saying, no, sir, the time of flight is less than the time taken for it to become perpendicular.
hmm.
Then during the motion of building, then time of flight will become greater, sir, if you throw the ball from the building.
Time of flight will not become greater. The path is such that where the velocity vector can become perpendicular. Hope you should understand.
But still, time of flight will be less than the time taken, sir.
What do you mean by time of flight?
Sir,
What do you mean by time of flight, first of all?
the object will be in the parabolic path, sir, during that time.
In air.
In air. So what is it, from where to where?
Till reaching the ground, sir.
So when it is here, okay, now it can happen, no? So what is the time of flight? Till here is the time of flight, or from here to here time of flight?
Till the ground, sir.
Okay, fine. So somewhere here velocity vector can become perpendicular. No.
Yes, sir.
not
Yes,
here.
that only my doubt, sir. And
Yeah.
now I understood, sir.
Okay.
Yes, sir. Yes.
It's a mere formula, but we must have this background. I know maximum students you stop it here only. You don't want to further analyze, but this analysis is what needed for us in the advanced level.